All right, let's go ahead and get started. Welcome back. Welcome back. So lab 4, a little bit better. A little bit better. Okay. So I've had a couple questions about this, and so I'm just going to ask everybody. If you're not sure whether or not you need a makeup to do a makeup lab, we are working on that literally right now. Adam is tallying the lab 4 grades right now, and when he's done, he will post them somewhere that you can access and figure out which labs you don't have credit for. And that way you know whether or not to sign up to come in. Hopefully this whole makeup thing works for everybody. If you're bummed out because it just doesn't work with your schedule or something, please don't stay silent. Let us know. I mean, we are doing this because we want you to have the educational experience of attending these labs. But we don't know how to fix a problem that we don't know about. So please let us know if something doesn't work for you. So before we get into Sokwa's lecture, just want to remind you of a couple due dates that are coming up. What's happening on Thursday? And why? Why is it due Thursday and not next week?
Want us to do it Thursday. Because
presentations start a week from Thursday, and that way people don't come to class, listen to the summary of the paper, and they go home and do something. That's what I'm going for. Okay. So what happens a week from Thursday?
Presentation.
Homework 3 is due. Sorry, what is due? Yeah, you're right. Yes. Homework 3 is due a week from Thursday. I am done with my implementation. I ran into some trouble. I was trying to convert the Enron data set last night, and it failed when I was sleeping. So as soon as I make sure that I can actually do stuff that is correct, I'm going to pass it off to Sokwa. He'll build the auto grader and open it for submissions. Okay? Also, this Thursday, is the last lecture with new material. So here's the timeline. Thursday, we're going to talk about cloud and web forensics. Next Tuesday, we have Jamie Winterton coming as a guest speaker. That's going to be awesome. Don't miss it. She's amazing. And then we have 4 lecture periods of paper presentations, a summary lecture where I'm just going to go over the semester content. Any questions you have, want to review, things that have been sticking out in your mind, or questions from the midterm that you didn't understand, need explained again. That's the day, and then the final. So we're very close to the end. Yeah.
Are you going to do like a high-level final expectation or points prior to that summary?
I'm sorry.
Like a list of, like, for the midterm, we covered, X things. Just hey, these are your big takeaways. Are we going to have something similar for the final or second half of the course prior to your summary day? Since we're going to have 2 weeks of presentations, what I'm getting at is, hey, that 2-week period could be used for study or review instead of having a summary at the very end. You have 2 days, okay? 2 days.
So, let me see if this matches your expectation, what you're asking for. You're asking for me to make available to you the summary slides for by next week. Is that what you're asking?
Just a longer break time in between. Yes.
Okay. I will work towards that. That's the best I can. That's cool. Thank you. Any questions about homework 3 or the project or the schedule for the rest of the semester?
Are paper material going to be on the test?
Good question. No. But what I am planning to do, thank you that I haven't mentioned this at all. I apologize for that. what I'm planning to do is have a little form for you to fill out while you're listening to the paper presentations of others, just so that you have somewhere to write thoughts and show me that you're processing information and not sleeping. Okay. Yeah, but no, I will not be testing you on paper material. That's, I feel like, doesn't make sense. Yeah.
When will an auto grader for the project be available?
I don't know. So we have been collecting some use case. Oh, that's another thing I haven't mentioned to you guys. Sorry. We're working on it, but I don't know. But I definitely want to mention this. So regarding the project, there are a lot of points in your code that it should fail because certain circumstances aren't met. Rather than us telling you what the message that you print to the console should be, what we want you to do is actually exit with a non-zero status. Okay? So when we're making sure that you're catching these error conditions, we don't have to parse the string, we can just check the return code that it's non-zero. Okay? Does anybody not understand what I just said? Totally okay if you don't understand it. I just want to make sure it's clear. I'm going to add it to the project description. I just haven't got to it yet.
So you basically, like in our code, we like exit 1 or 2. And
Yes.
go 1 or 2.
Yes. Yes.
And then, like, if it's an error, there's only one kind of error.
I don't care. All we're going to, so if you want to have like different error codes for your own like debugging and testing, that's totally fine. We're just going to check that it's a non-zero exit code. Okay. By the way, it was made clear to me through a conversation I had with a student in the class last week that maybe I haven't emphasized this enough, but you do not need to use Python for anything in this class. Anything. Apparently that wasn't clear. Someone came to me with a concern that they didn't know Python. And so they felt like they were doing terrible in the class and were concerned about the project. You don't have to use Python for anything. I would use Python for everything. And so I'm trying to make the same available to you, but I also don't want to impose my favorite language on you if you hate it. So as long as it compiles and runs in Ubuntu 1804, I don't care what you write your programs in. I hope that that's clear now. Okay, you have it. Yeah.
For the presentations.
Yes.
So I'm going to submit on the Racer PDF version. Or is there a way to submit it? Yeah.
Email it to us, to the three of us. Yes. And say that one more time. What?
Do I still need to have a copy of the slides?
No. No, don't worry about that. That's just for if you're doing an extra credit report, which if you're doing a presentation, you're not eligible to do anyway. Thank you. That's a good question. Any other questions? Administrative. Yes.
Are there any loss of points on the paper report if it's not close to 4 pages and it goes longer than that?
Did you reword that? I was confused.
Say the report is 8 pages
Yeah.
instead of 4, is there any loss of points?
Oh, man. What do you think, guys?
No, because it says at least 4 pages, not like exactly 4 pages.
Yeah. If I said at least 4 pages, no point to that. Yeah. Any other questions? Great. I'm glad you're understanding it enough to write that in the paper. Okay. Then we'll go ahead and please welcome Sokwa. Well, you can introduce yourself. Everybody, welcome Sokwa.
Thank you, Mike. So, hi, I'm Sukwa. I'm the TA of this class, in case you don't know yet. And I'm a second-year PhD student in CS at CEFCOM Lab. And today I'm going to give you a lecture on malware forensics. Okay. Okay, so before we look into the details of all kinds of malware, let me introduce some common types of cyber attacks that are dominant today, internet. So first is phishing. I believe Adam gave you a good lecture on phishing, so you have a good knowledge of the topic. And there's a malware. It's a use of malicious code to make your computer do whatever attacker wants it to do. And SQL injection is injection of SQL request SQL to the database website or website web server to reveal sensitive information such as users' credentials or credit cards information, etc. And cross-site scripting is not exactly attacks on is an attack on the server itself. It's more like injecting the malicious script, like a JavaScript, inside the source code of the website. So whenever the user visits the website, it steals the user-sensitive information, such as your password. And other attacks include man-in-the-middle attack. Simply, attacker sits in front of the you and the server, client and server, and sniff your network traffic to store the your information. And denial of service is a compromise. It's compromising the availability of the network services. And other attacks include brute force and dictionary attacks, etc. Today, we of course gonna focus on malware. So, what is malware? Oh, before we go into the definition, let me show you the current the severity of malware attacks. So as you can see, I just found those reports headlines with one single Google Googling, so Google search. So as you can see, especially in 2017, overall malware variants were up by 88%, yeah. So that shows just how destructive malware can be, and it is one of the most popular attack method in today's network security. And it is a serious problem, basically. So what is malware? Malware is just any kind of code malicious that does malicious thing on your computer. So basically, the more formal definition is a set of instructions, whether it is CPU instructions, commands, or script that run on victim's computer and make the system do what an attacker wants it to do. So that's why some products, the software products from IT companies, are accused of being a malware because they do something that you don't want it to do, like collecting your information, your hardware information, and such and such. So purpose of malware is, to steal your information and do malicious thing on the companies, such as but on the machine level, on your host level, it usually steals or deletes your sensitive files or information. But on the large scale, more on like a network scale, it is used the network of infected hosts are used to send massive amounts of spam, or attackers use those network as a relay to conduct more sophisticated attacks like DOS, distributed of denial of service. So malware forensics is basically conducting forensic analysis on the malicious code. So there are two ways to do it. So first is static analysis. So it's basically investigating the collected malware without running it. So you debug it like tools like IDA Pro to go through the actual control flow of the malicious malware, and trying to collect as much as information as possible, such as what functions this malware executes, or what kind of dependency this malware does have, so that at the end, you make a precise conclusion, but a precise assumption or conclusion based on the evidences you collected. The other kind of analysis called dynamic analysis, it's basically running the malware in a controlled environment like a sandbox environment to see what the malware actually does by running. So you monitor various activities on the system like process, memory, and network activities and etc. and get the actual activities of the malware. So we'll go more in depth about this in a few moments, but usually static analysis is both are done whenever the forensic analysts collect the malware. But more important thing is it's not only the malware forensics is not only about analyzing the functionality of a malware. It also involves how the victim host got infected by the malware. So whether it was by the phishing, or it was from the email, or it was from other infected hosts. So basically, oftentimes it involves network forensics. So here are some famous or infamous incidents by malware in the past. So, for example, Melissa was done at the early age of email. So the malware posts itself as a Word file containing passwords for pornographic sites. So whenever the user opens it, it infects it copies itself to the kernel of the host and to steal your data. And Operation Aurora is targeted towards major IT companies such as Google, Yahoo, those IT companies to steal their intellectual properties. And recently, ransomware got famous. So CryptoLocker encrypts the sensitive system files, system files on your systems and asks you for money for the decryption key. And Mirai, which is a Japanese word for the future, but not necessarily originated from Japan, is infected massive amount of a lot of network of Internet of Things, and infected them, created a botnet, and attackers use them to conduct distributed denial of service towards the DNS server. So it shut down the entire network connection on the east coast of the US. So the access towards the Netflix, Twitter, and Reddit, all those sites were unavailable. Yeah. So there are various types of malwares, including virus, worm, Trojan, backdoor, blah, 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 but I will go into details of this in a second. So how usually we counteract towards these malwares? So there are software called anti-malware software. There are two kinds of anti-malware software. One is called intrusion detection system, and the other is called intrusion prevention system. So the distinction between them is in reality, it's pretty vague in my opinion, but the major difference between those two is whether they can block the actual attack. So in IDS only detects the attack and let the administrator know, hey, there was an attack expected. But IPS, like firewall, detect and the block filter, drop the traffic or block the actual attack and report it to the user. So the major example of IDS is your antivirus software. Anybody has antivirus software installed on your Windows? Okay, but in my opinion, they are purpose of those antivirus program is just to make you feel that you're safe. Because they're basically database of known malware signatures. So signature is created, it's a fixed amount of byte that identifies the malware. So it transfers the payload of the malware to the unique signature that can be detected by those software. So what is the most naive way? What if I ask you to create a fixed amount of signature of this binary? What would you do?
So with like hash of.
Exactly. So hash is I would say most naive ways to create a hash. So you already know at least a couple from your assignment. But what is the problem of that? What is the problem of using hash?
So if they change even a single character in the file, then the whole hash will be different.
That's a perfect answer. So attacker can create infinite amount of the same kind of malware with different signature by just changing, one bit of your program or one bit of your programs of binary, so that it can create, totally different hash. So then, what other ways those antivirus software companies actually use to create signature? Do you know any? So if you are interested in that topic, my advice is that it's actually a complex problem, and it's not in the context of forensic in this class exactly. So it's a good material for a good amount of lecture. So, but yeah, I just wanted to introduce the concept. So let's look at the first kind of malware, which is first virus. So virus is a program that can infect other programs by modifying them to include a possibly evolved version of itself. So it's a code attached to a target binary and execute whenever the target executable is executed. It executes basically itself with the target binary, and it's replicate itself to infect other binaries. So it's basically originated the physiological term, the virus, and the simple example of virus is the code of the malware, the virus attached to the target host, and whenever the target host executes, it also executes with the target host. But it's very easy to detect, because whenever the infected executable executes, it also does the malicious thing. So usually, the usual example, the way actually virus works now is triggered by a certain event, like whenever the certain part of the code of the executable executes, or certain time at a certain time, that triggers the malicious code to execute. So you might ask, we can just remove the malicious code by looking at the source code, but the same reason as why you cannot just look into the source code of the other commercial software product, attackers also obfuscate their code using what's called packer, one of the obfuscation method. So packer actually usually used to compress the payload of the payload, but it is also used to obfuscate the source code, so that you cannot just simply look at the source code. So there are various ways to obfuscate the source code using the packer, such as encryption and randomizing. an anti-debug technique such as including a fake jump instructions into your code, or adding the some garbage and junk in the code in the binary, or using the virtualization, etc. So normally, one of the first job when the forensic analysts obtain the malware sample is to figure out whether the sample is obfuscated or not. When it is suspected to be malicious. The second kind of malware is backdoor. So it is a secret method to bypass normal authentication or encryption of the system. So note the word secret method. For virus, I use the term program, but for backdoor, I use a method because it is not necessarily a program. So any method you use to bypass the security mechanism is called backdoor. So in early days, when like mainframes are used, network administrators use the default password that is universal to their products, all their products, so that they can just use one password to access all their product to mainframes. That is also called malware, backdoor. So it is not necessarily have to be a program. So the other example is called Clipper chip. It is hardware developed by the U.S. government in 1993 and planned to be implanted on network devices for access by law enforcement and government agents, but that did not go in effect actually. So they just closed the project. Actually, they need to do it. So when the infected, the backdoor opens like a random port inside the infected host, the attacker can simply communicate to the infected host without the user knowing. But sometimes, if you have firewall usually filters. If you have like manually set the firewall to filter every other traffic other than what you actually need, they filter all your incoming traffic, and in that case, even if the backdoor is sitting in the infected host waiting for the attacker's communication, cannot receive the attacker cannot communicate to the infected host. In that case, reverse backdoor is used. It's actually the backdoor initiate the communication towards the attacker, so that it can bypass the filtering of the whatever security mechanism. Okay, Trojan. Trojan is actually a program that also, basically do malicious things, but it allows unauthorized access to the victim computer also. So it's kind of combined with the concept of backdoor and the virus. So one simple example of this is a program called Waterfalls and Screensaver program that distributed in early 2000, no, before 2000, even before 2000. It was a free Waterfall screensaver. So, you would download this and enjoy the cool Waterfall screensaver on your Windows XP or 98 screen or whatever. But when run, it unloads hidden programs, command scripts, or any number of commands with or without your knowledge. So then, today, we have GitHub, and if you have a free software, you upload on your GitHub, and people can see your source code. But back then, we didn't have that, but there are also other lots of freewares, that doesn't actually disclose their source codes, then how can you trust them? So Ken Thompson, at his turning over the acceptance lecture, said maybe it is the people who wrote the software we have to trust. So how would you, what would you need? Like, if someone sent you your photo that you took last week, then you went hiking, how do you absolutely trust that? Well, you would never know. I mean, I might inject a shell script, in that image file and send it to you just by running it. If you're running Linux, specifically Linux, because I can own you. So basically, it leads to, my point is, it leads to the problem of root of trust. Like, you gotta believe something. I'm gonna talk about more of this when I talk about rootkit, but what would you trust? You would trust your OS, you would trust your BIOS. Where would you put your root of trust? So next is rootkit. Rootkit is more related to your kernel of your operating system. So rootkit basically disguises itself as a critical system file that you must have to run your kernel. But it acts, it does all kinds of malicious things. I'm gonna show you the demo later about this. Yeah, so basically it is comparatively harder to detect compared to other kinds of malware, because they are simply, I'm the critical file. You cannot delete me. You cannot. If you delete me, you cannot boot your computer. Boot up your computer. So one kind of rootkit is called kernel rootkit. So basically, rootkit overrides itself in some kernel library and create a process that will interact with other process to do malicious thing. More specifically, Windows kernel, all kinds of dynamic libraries and CentOS kernel, and all processes using interrupt request to communicate with the kernels. So as a forensics analyst, you should have knowledge about what is the critical files for your kernels and how they operate, so that when you analyze a rootkit, you can detect any malicious activities. So this is one example of a kernel device driver rootkit. So first, the rootkit overrides some functions in the NTOS kernel, and then it creates a new pointer in the system service dispatch table, and whenever interrupts come in from a processor, it points to the malicious function of itself. The other kinds of rootkit is called bootkit. It infects your BIOS or master boot record, volume boot record, or boot section during your computer startup. So even before your OS loads, your system is already infected. So it is hard to detect it is hard to detect it on upper layers, even on OS level. So this leads to the same question: where would you put your root of trust? You absolutely believe your OS is safe because those kinds of malware exist, and even before your OS boots up, you can be infected by those kinds of malware. So simply when your NVR is bicycle bridge is infected, then the upper layers, all those security mechanisms on the upper layer becomes useless because they can simply bypassed. Okay. And worm. So it is not as popular as it was, but worm still exists. It's a self-replicating program that uses a network. So it uses a vulnerability in network services like buffer overflow to replicate itself and spread throughout the network. So one in Morris worm is known to be the first one. So it is developed by a graduate student. I forgot his name. I know his first name is Morris, but anyway. So anyway, he created this worm to demonstrate the vulnerability he found, but the mistake was that he so the worm decides whether to replicate itself or not by sending a message to the sending a message to the kernel saying that if there is any other process like me is running. If it's yes, then it stops. But when it's no, it replicates itself. But to bypass this defense, he created even if it got yes answer by the chance of 1/7 times, it still replicates itself. So he thought this was small enough to control the spread of the worm. But 1/7 is still a large number in real world. So it went beyond the control and infected about 10% of the entire internet at the time. So they had to segregate the internet, the networks, but in the end, you know what they, any of you know what they did to take this? They actually shut down the entire internet because back then it was only 60,000 hosts. University computers only connected to the network, so they just simply had to shut down the entire internet. So the other examples of worm include code red worm. It's a direct descendant of Morris worm, infected more than 500,000 servers, and it's programmed to make them to go infinite sleep mode on July 28th, and it costed about 2.6 billion in damage. And about one, it actually spread throughout email with the subject "I love you" and the attachment "love letter for you" txt.vbs, and infected a lot of people who are lonely, and costed about 8.75 billion. So what are the distinctions between those kinds of malware? So virus and Trojan, they actually rely on human interactions like social engineering or emails to make them spread. But the worms are self-contained and replicate themselves and may spread autonomously. And virus, specifically virus is not, while Trojan and worm are themselves are separate programs, but virus is code attached, embedded, or binary or target is zero. So am I clear on this? Yes. This is on.
Yeah.
Okay, thank you. Okay, so, and browser hijacking, just simply redirecting you to malicious website. So all I wanted to do was read the Cinderella script, the script, but it directs me to get new me. Don't know what it does. So, and Edgar, anybody had those kind of thing in their Windows 98 XP? Yeah. I had a couple, but I don't know what you have to do to get this amount. But yeah. And browser toolbar. Yeah. Yeah, blocking the more than the half of the screen. Ah, those days. Yeah. And ransomware got, as I said earlier, and ransomware got popular these days, and they ask you for your money. They hold a hostage of your sensitive information, of basically your access to your computer, and they accept the Bitcoin also. Interesting, but and also mobile ransomware are popular because as you know, Internet of Things, mobile networks, 5G is coming. Are you excited? Man, really? Okay. So 5G, just FYI, 5G security in 5G is going to be extremely important because 5G, all the IoTs, all the smart cars are going to be communicating with your base station, and there are a lot of vulnerabilities, known vulnerabilities already in LTE that applies the same to the 5G. So, but all those companies, all they care about is just deploying fast and make a lot of money, as much as possible. So just so you know, the security standard for 5G is not there. Not there. Just so you know. So ransomware, they locks up San Francisco. So they also infected some critical infrastructures like railroads, transportation, energy, or healthcare. Hospitals got infected also. All those sensitive information. Okay, so botnet. Botnet is not a kind of malware. It's actually a network of infected hosts, those hosts infected by malware. Those are called bots or zombies. So attackers try to infect as many hosts as possible to create all those army of zombies. All those bots communicate with the attackers. They use the CNC, what is called CNC server, command and control servers. The attacker issues a single command on the one single server, then it spreads throughout the entire network. So it is one of the most critical threat to the internet. So when I say botnet, they usually mean millions of compromised computers, and they are sales. They also are for sales. In the dark webs. For if I remember correctly, 1 million access to 1 million bots is about $80. So you can get access to 1 million bots to do whatever. I don't know plan to do, but yeah. So they are basically used to carry out specific, more sophisticated attacks such as distributed denial of service, spam forwarding. You know, about 70% of all spams are related, forwarded from the opponent. And this report reported that the entire host connected to the internet, among them, 25% of this 25% of them are infected by malware and join those army of zombies. And now, finally, malware analysis. So, malware sample is executed in a controlled environment, which makes it possible to observe the traffic that is exchanged between the bot and its command and control center. So this is what I mentioned earlier. And actually, there were research attempts that actually joined the bot, the army of the bots. The researchers actually joined the army of the bots and tried to analyze how it operated from the inside. I wanted to explain more detail about the research, but due to the time constraint, I will post the paper, the summary of the research. And malware analysis also involves, reverse engineering. Reverse engineering is debugging the code, using the tools like IDA Pro to get the control flow of the program, your program. More specifically for Windows, you can get a file signature which is called the P format. P stands for Portable Executable Classification, based on object file format for Windows 3.1 and later versions. So P by just looking at the P specification of the binary, you can get a lot of information like machine type, and how when it's compiled, and what format of the array, whether it is obfuscated or not, which tool is used to obfuscate the binary, the source code, etc. So Windows P format includes executable, dynamic link libraries, system file, virtual device driver, STR. What is STR? Script file. Script file, yes, script file. OCX is object file for Visual Studio. So static analysis, as I mentioned earlier, involves manual investigation using debugging and VDM-based memory analysis. So have you used IDA Pro before? Okay, hopefully I can show you the demo of IDA Pro later. But IDA Pro is used to go through the functionality of the program and control flow of the entire program, and in which point it jumps to other functions and etc. So you can understand the functionality of the binary. Dynamic analysis, you use VM or sandbox environment to analyze the collected malware sample by actually running it. So in this controlled environment, you monitor process, file access, DLL, registry, network connections, and etc. All kinds of activities that's going on in that environment to get the exact activity of what that malware is doing. So there are also other tools for doing this called Anubis. Anubis is, I think, open source. No, not really. No. Yeah. So there are some famous tools for doing dynamic analysis. So, right, so let's show you I prepared a demo. So let me show you. Okay.
Is that enough room?
Switch to.
In case you can't tell, Sokwa has selected one of you lucky students to hack into your computer right now, so that's where he's doing the demo. Just kidding.
Okay, so let me demonstrate some simple static malware analysis. So I plan to create the make this in-class lab, but due to our circumstances, I decided to just simply demonstrate this. So.
Circumstances meaning crappy laptops.
So your forensic teammate, so the scenario is your forensic teammate has acquired a program from a computer criminal's PC. So it is believed that the program is malicious. So as a forensic expert in your team, it is your job to figure out the functionalities of the suspicious program. So let me do this. So this is the evidence files collected. Those are actual malware. So the first question is, are the signature file going to be malicious? So basically, are they known malwares? So the answer is yes. And to check that, I simply check the database of known signatures, malware signatures, by uploading this file. And 41 out of 70 databases responded with malicious, determined it is malicious. So it is malware, it is a Trojan, and other 29 out of 70 database useless, those antivirus programs, Bitdefender and NCSoft, literally they're just benign. And we have the other library. So library file, which is DLL, and 34 out of 70 database. Since database is said yes, it is malicious, so I would say yes. Yes. And when is the files compiled? So as I mentioned earlier, we can just simply look at the P signature of the Windows executables by using the program called PView. And we can, let me just check the executable first. So there's a P signature here, and you can check the NT header. This is the signature, and you can see this P signature is there, and you can see all those header, and the date it is compiled is on Sunday, December 19th, 2010, 4:16 p.m. And for the other DLL, so it is created a few seconds after the executable compiled, so I would say 2010. So I would just simply say 2010. December 19th, whatever. And are they obfuscated? You can also check this by another program called PEID. It's more simplified form of PView. It just extracts the only some sections of the headers, and the section it's in it says it's in plain text. Sometimes it will say RSRC, which indicates a raw source, or R data, which is raw data. So this is not obfuscated. But this is I did not obfuscate this file for the sake of demonstration, and it's not obfuscated. So what are the functionalities? So the one part, so we can check the all the we can extract strings that are the names of the functions and the dependents of a binary, of those raw binary. Just uploading, and you can see it. This file requires kernel DLL file, and so from this I assume this is a kernel rootkit, and here you can check the function names of this executable. If you have a knowledge of a kernel file, this kernel 32 DLL file, it should not have, it never has functions like create file, copy file. It should never, the kernel never create a file, as you know, only interacts with the process. Kernel 32 is used for memory, resource management, and interaction for the between the with the process. So we should never have that. And if you look at the other DLL file, the first thing I noticed is that it requires WS2_32 DLL file, which is used for network communication. The kernel requires this file for the network communication, but once again, kernel itself does not require any network communication. So this is anomaly, and you get here, it creates a process. It should never, this kernel 32 should never have a function that creates the process. And it went to sleep. It goes to sleep. Why would it have a sleep function? This is weird. So you're getting a picture of what it actually does. So functionalities, copy, and create, process, and sleep, and it also requires network connection. So any such, actually network connection to WS2_32 should go here because it should never have any dependency with that file. So any network dependent activity, specific network activity, figure out that, and I will run another Windows. Yeah. I will run another program called strings. What it does actually extract any ASCII text embedded in your binary. So anything that can be readable, it extracts from the binary. So exe and the evidence exe. Okay. Ooh. Strings. Yes. Thank you. Yeah. Okay. So it has all the function names we already found: sleep, created, process, kernel, WS2_. Here. If you see this, can you see this? So there's a strange, seems like an IPv4 address embedded in this binary. Why would a kernel file have an IP address embedded in itself? And if you the executable itself, instead of kernel 32, it has kernel ne 132. Instead of, this is kernel 32, and this is looks like kernel, but actually at the end it is 1 instead of L. So with all those information, let's draw a conclusion. So we found all the suspicious functions: copy file, create process, sleep, and we found suspicious dependency, including WS2_32, which is used for a network connection, and we found IP address, and embedded in those files, and we also found the what did we find? Okay. All right. We also found, oh yeah, fake kernel. So my conclusion is that this is a kernel rootkit that copies itself to disguise itself as a kernel 132, not kernel 132, to make it look like, and then create a process using this create process function and going to sleep. And open the back door to contact the CSE server whose address is 127.26.152. After this conclusion, you actually go into dynamic analysis by actually running the malware in a controlled environment to confirm that your conclusion is right, or you just don't need to running it, you just take it by running it. And yeah, that's a simple demonstration for static malware analysis. And I have IDA Pro. 6650. Oh, what? Actually, okay. Let me see. Okay, I simply have another. Okay, let me demonstrate simply have another malware, not exactly malware, but another suspicious executable called 469.exe, and it requires an input password. And let me guess, wrong password. It seems to me like it just a binary that requires only accepts the correct password. So let's look at the let's good. Let's look at the data flow.
You have too many browser toolbars.
Yeah, toolbars. Okay. This simply, so it looks daunting, but if you understand all the instructions, it's actually fun. No, trust me, it's actually, yes. Where is it? Okay. So you see all those jump instructions and wait. Okay, my mistake. I prepared the wrong file. So I will post the lab to go through it. I post the lab to go through the entire instructions with the entire instructions to go through by yourself, so that with the tutorials, I was actually gonna post the tutorial only, but I will post the actual instructions to go through this exercise so you can do it by yourself. Trust me, it's fun. So there's a hidden function in this binary that doesn't even appear by simply executing it. So your job is to find the extract the secret information. Okay. I apologize. So, okay. Right. That's it. Thank you.
Any questions for Sokwa? Nothing?
Just
Yeah.
one thing specifically, what's the fake jump thing you're talking?
Wait, what?
The fake jump?
Oh, fake jump. It's a simple instruction for you to create a fake jump, some junk, so that the analysis cannot get the picture of the. Yes.
I've heard about like things that I got the one things that I've heard of like concept malware, because I've heard of firmware of the malware. I did like keyboard firmware.
Oh, wait. Yes, there's a malware for people, device drivers.
Are those the real thing? Where do they fit?
Oh, so those are the device driver root that I'll say, and what they are used for is key of a library type. You can simply read it and send it to the hacker so that they can see whatever. Other question? Thank you.
All right, we'll see you guys on Thursday.
Yeah.